Okay, maybe we should start, and then we hope the other people will join and come in the lobby, because there's somebody now in. So I'll say thank you for you joined the webinar. The technology moves so fast that new technology required a better solution. So in this webinar, you will see the latest technology from Radiall to solve this challenge that exists actually, and as well the benefits. So I hope this next generation of solderless RF board-to-board interconnection will give you a good input for the next generation for your applications here. So and you are very welcome to ask in the chat and interrupt in the chat. Please mute your microphone. And I will say welcome to you, Perek from Radiall. And I have one input. Sorry, Perek. If you maybe Perek will show that, but if you would like to have a bigger screen, please with the name Perek Møller, that is 3 dot, and you can use this in Danish. It's called tilpas til rammen. That will be the size will be bigger, the latest one there. So yeah, you're welcome, Perek.
Thank you so much. So good morning, everybody. I'm glad to be with you today to introduce the solderless solution from France today. We speak about the product range. We call it the IMP, but we will discover the range later. So first, I'd like to mention something. We will speak about the beamforming. So where we could find the beamforming, in fact, everywhere. Beamforming could be in the communication. It could be in SATCOM as well for the plane, for example. It could be on radar detection as well. And also with the directed energy. We use also some board-to-board solutions. So it's beamforming is everywhere. What is the beamforming? I'm sure you know more than me, better than me, the beamforming technology. So we are using this kind of a matrix of antenna to display, to send a signal and to receive a signal. And we will beg our attention today for the interconnection between the antenna we have here on the front side and the link we have between this antenna to the TR module we have on the back side. So we use a lot of connectors in this part here to make the interconnection between the antenna and the TR module. It could be sometimes cable assembly according to the size of the equipment, but more and more often it's many coaxial connectors in order to densify the equipment. Where we find the technology, as I mentioned before, everywhere. So if we have a focus on defense, for example, we can find the beamforming into communication onto the ground, for example. It could be also on the radar application on the ground. It could be in the air with the jet fighters and the drones, the big drones. We speak about mainly the radar we have in front of the nose in the jet fighter. So it's a quite heavy radar. It makes sense to place it in a big platform. So jet fighters, this kind of heavy drones also can carry the radar application. On the sea as well, we have some radar applications, like it is on the carriers, jet we have here. And we have a big radar on the top of the mast. So this one is also having the board-to-board solution. And another one is on a different side of the mast onto a frigate, is also having beamforming and coaxial solution. And also, as I mentioned before, with the space activity. So space means in the space, of course, with the satellite, but also on the ground and the vehicle communicating with the space satellite. If we have a look onto the beamforming architecture, so if we explore this kind of antenna we have here to this array, if we take a part of this array, like this small module here, we have this kind of architecture. So coming from the right-hand side here, we have the antenna side with a small matrix we have here. And we need to interconnect this matrix to the TR module we have on the back side. To do that, we will use some connectors. We will discover later what could be the connector side. Between the TR module, we have another plate, another conductive layer. This one is usually called the manifold to collate, to combine the different signals, to send a common signal or different signal to the TR module. And between this manifold and the TR module we have here, we need to interconnect again with different connector solutions. So it could be RF and DC connectors for this purpose. Between the array of the antenna and the TR module, we use a plate, and this plate is quite special. We call it the cold plate in order to cool down the system. So I will come back to later to the cold plate. So what is important to understand that we have, in fact, different technologies today in Radiall to achieve the board-to-board interconnection solution. The first one is quite common, using the SMP product. So it's made of one top receptacle, a second bottom receptacle, and in the middle, we have a bullet to achieve the interconnection between those two receptacles. So it could be a fixed bullet adapter like it is here, and it could be as well, like it is in the picture, with a spring bullet. It means this one can accept a more important board-to-board distance, axial tolerance. We also have the possibility of a cable assembly, but it's not the purpose today to speak about this kind of a technology. The new technology we are now placing into the market since 2 years now for defense. This is what we call the solderless solution. So it means we need to interconnect the radiating element, the antenna side, for example, on this side here, to the TR module we have on the back side. To do that, we will place only one connector, only one component between those two conductive layers, and this product is placed into a cavity to make the interconnection. We just have to compress the connector, and we have the function. And it's working up to 40 gigahertz today with this kind of solution. We call this solderless technology the IMP solution, Interconnect Micro Miniature Pressure Control. The big advantage of this technology, it's first, it will be the size, the weight of the product. So this is what we call the SWAP-C compliant. It means we have a product dedicated to the architecture where we need to have a very dense and very lightweight integration into a system. I mentioned before that we use a cold plate, and we have a cold plate into the architecture. So the cold plate is quite often mandatory for this kind of application, the beamforming. The reason is we have to cool down and to keep a suitable temperature everywhere onto the surface of the equipment. It means we can't accept to have a low temperature on one side and very high temperature on the opposite side. We need to have a constant and the same temperature everywhere, and this temperature has to be managed. For example, it could be 30 degrees, could be 40 degrees, whatever is the need, but to have something constant. So in this case, we use some cold plates to cool down the system. A cold plate could be a passive one with a cooling fin surrounding the plate, like it is with some radiator we have on a computer, for example. And it could be also with a liquid cooling system. So it means in this case, we have some complex liquid cooling system made of a plate, like we have on picture, having some liquid inside it to cool down the system. So we will use, in fact, the constraint to use this kind of a cold plate to place our connector inside the cold plate. And the cold plate is becoming the support of our connector. So the cold plate is in fact having three functions. The first one I already mentioned before, it's to cool down the system. And for us, we will have two additional functions. The function number 2 will be to localize the product onto the PC board in X and Y direction. So we have the IMP solution just here. We engage this connector into the cavity we have here, and we localize the product with the cold plate we have here. On my sketch, the cold plate is very simple to explain the main function of the product. And when we compress this conductive layer to the opposite side with the antenna side, for example, we use the cold plate thickness to fix the board-to-board distance. The connector itself don't provide the board-to-board distance. This is a cold plate to define the board-to-board distance. It's very important to keep in mind that in Radiall, we design the product according to your wish. If you have a cold plate about 5 mm, 6 mm, 8 mm, we will design a specific connector for that. You don't need to look for a specific connector. We will design it for your application. So as I mentioned before, the interconnection is quite simple. We need to interconnect the layer 1 to the layer 2. This is what we call the antenna side to the TR module, for example. And to do that, we use a cold plate in which we will engage our connector. We just have to drop it into the cavity, and it's a very simple process. What can be the benefit of this kind of a technology? The first benefit is, for example, in terms of a design. When you design such a TR module, for example, you need, for example, to place a connector on the TR module to link it to the manifold you have on the backside. To do that, you will purchase a connector from the catalog on the website, and this one is having different contacts inside the body and a specific board-to-board distance. So first, you need to find the suitable board-to-board distance with existing connector. It could be a headache. The second point, and very important point, when you place this kind of connector on a specific area onto the PC board, you need to create a very complex routing to go to the connector. So it takes a lot of time. Time is money. So with the benefit of the IMP architecture, you save it. How we save this time? It's because if we speak about the shielding architecture we have on the backside of the TR module to the manifold, for example, so we can explain that this aluminum plate we have here is the shielding architecture. We have a wall thickness here, and in the wall thickness, we can place our connector because we can design the connector according to your wish again. It could be one single roll, for example, about maybe 2, 3, 4, 5 contacts we can place on the wall thickness of the shielding architecture. For the DC connector, we will see later, it will be the same. We can design the DC connector with maybe 1 line, 2 lines, 3 lines, as it is on the picture. So in the design phase, you save a lot of time with the IMP solution. In the design phase as well, we have also another benefit, a very important one. It means when you design your system, usually with when we sign an NDA, of course, with our partner, with our customer, we provide you the 3D model to make your simulation by yourself into your system. We work in full transparency. We provide you the 3D model. You will double check what will be the performance of our system directly into your system. We recommend to use this kind of a pad for one connector. So it's a recommended pad, but of course, according to your substrate, maybe you will have to adapt it a little bit to have the suitable impedance. But we recommend this kind of a pad at the beginning. And after that, just think about a cylinder having a center contact, insulator, and a ground contact. As I mentioned before, to use the IMP is quite simple. You just have to create a cavity into your cold plate and to engage, to drop your connectors into the cavity. It's a very simple process. In terms of RF performances, I think it's maybe the main benefit of the IMP solution, especially for radar application. If we have a look here onto the this curve, this is a curve we check our product, the one we have here on the right-hand side. This product, this is the worst case for us because it's a very long product, about 16mm length. And even in this condition, you can see that the curve here, we have something around 0.2 dB insertion loss. It's very good. If we compare to SMP, SMPM, usually the value of SMP, SMPM is something about 0.6 to 0.8 with the 3 components and solder onto the PC board. With the IMP solution, at 40 GHz, we just have minus 0.20. It's a very robust product. We apply some vibration tests, shocks, and different tests, of course, you can imagine, because we place the connector onto jet fighters, missile. It could be also in space. So we have some different tests we perform onto the product. So it's a very robust and reliable product. We sell it since quite a long time now into the market. Another topic that could be also interesting, especially at the design phase. I see more and more often some companies, when they design a system, they think about the calibration. Before to create the system, they already think about what will be the calibration, how we can calibrate my system. With the IMP solution, it could be very simple. You can imagine to have the TR module and you want to check your TR module, for example. So one possibility could be to use, again, the cold plate, fixed onto the TR module, with the IMP already placed into the cavity, and with a test jig, like the plate we have here, with different connectors inside it, just having a pad we have here, touching the IMP solution, and we can double check the perfect interconnection between the IMP and the test jig. The big advantage of this kind of structure here, we are just checking the extremity of the feeding line just before the antenna. But of course, if you want to check your antenna, we can do the opposite way in this case. It means we could have IMP solution here on the back side of our connectors, touching the antenna side to make the test on your equipment. Another possibility could be to use this kind of multiplexer. So this one is something I understand from the Rod & Schwartz company, for example. They have an interesting white paper on their website, and they explain that for active antennas, for beamforming, they explain we can use multiplexer to combine the signal together and to have only 2 ports output onto your equipment. With this kind of a technology, solderless solution, we save a lot of time. Just for your information, I got a remark from one customer. Usually they take 2 days just to plug all the cable assemblies from the VNA to this side here of their equipment. With the IMP solution, within few seconds, you make the interconnection. Of course, the first time you have to connect the cable to the test jig, but after that, you just have to repeat to close the system onto your system. In terms of maintenance, of course, maintenance is quite easy. We just have to drop the connector into the cavity. If you want to replace something, it could be the conductive, the electronic board. It could be to make something on the antenna side. In this case, you just have to open, you replace what you have to replace or to calibrate what you have to calibrate, and you close it again, and it's working. Very simple. And the big advantage also, you can do the maintenance directly onto the field. There is no need to go to the lab to remove the solder you could have on some connectors to replace it. You just have to open here and to replace the element you want to replace. It's a product designed and made in France. So it's ITAR-free. There is no regulation on this product. We can sell it everywhere in the world, especially today with what happened today in the world. It's very important to keep the design and the manufacturing in Europe. The range can be defined as the picture we have here. So we have the first one, we call it the IMP HD for high density, because the diameter we have here on the ground contact is only 2.8 millimeter. It's a very small product in terms of a diameter. And the board-to-board distance starts from 13.4 millimeter. So this product is having another benefit. You can see we have a spring here. And with this spring, we have a more important axial tolerance for the connector. So it means we can accept a more axial tolerance between 2 boards together. The second range of the product will be the IMP LP. LP for low profile. Low profile because the initial one was the first product we have here. And this one is having a board-to-board distance only 1.41 millimeter. It's a very, very small product in terms of a board-to-board distance. Based on this technology, on the interface we have on the top surface here of the connector, we created some additional products. We have a new range now with this kind of a product having a more important board-to-board distance. It's a full solderless solution on both sides. We have another one here. Maybe this one is about a 6 millimeter board-to-board distance. We can combine the IMP into a hedge receptacle to have maybe one single, 2 channels, 4 channels together in one receptacle. We have also another one, this first product we have here with a probe on the backside. We can imagine to go directly to the own antenna, for example, and to have the feeding line created by the IMP itself. And we have another one. This one is also interesting. We call it the IMP LP hybrid solution. Hybrid because we have the IMP technology on the backside here, touching the PC board, and the opposite side is having another interface. That could be SMA, SMP, SMPM, for example. The big advantage, benefit of this product, you can see we have a thread on the surface here. It means we screw this connector into the front panel equipment, onto the chassis. and the IMP is touching the PC board we have on the back side of the panel equipment. So on the front side, you have SMP, SMA connectors. This product is touching the PCB solderless solution. If you need, again, to dismantle, to repair something, do calibration, you can open your system, you can change what you want and to replace it. Very easy. Also, this product is very important, and we sell it with quite high volume today for different companies, for different applications. The last one we have here on the right-hand side is a little bit different. This one, as you can see, is made of a center contact just here in the middle with the insulator. There is no ground contact. If you remember, at the beginning, I mentioned that we are using usually a cold plate into a system to cool down the temperature onto your equipment. This cold plate is made of a material to cool down the system, to dissipate the temperature. So it means usually we use copper, aluminum, a conductive material. So if we use a conductive material for the IMP, for example, in this case, we engage in a cavity our solution with just the insulator and the center contact. Inside the conductive cavity, it's becoming a full coaxial line. This product is working up to 40 gigahertz, where for the other here, this one and the first one, they are working at 20 gigahertz maximum. There is another benefit of the IMP-SR. The IMP-SR, we can use the same contact architecture we have for the RF. If we place it into another body, another insulator, like it is here with a double channel, we can have maybe 2 channels, 4 channels, 6 channels, and we can adapt the channels according to your wish. So it could be, for example, like it is on the background here, with 6 channels. It could be 4 channels in one body. It could be in multiple lines. We have different products with 2 lines, 3 lines. It could be 6 contacts, 8 contacts, 16 contacts. It's really according to your wish. We design this product according to every customer needs. It's not a catalog product. You have some TDS available, of course. We have some 3D model available, but every time we design this product for a specific need. So that's it for this quick introduction about the IMP solution. Now I'd like to give you the opportunity, if you have any question, if you want to go in more details about one product range or another one, this time is for you. Do you have any question?
I don't think so, Perek. Not now, but maybe later.
Maybe later, yes. So anyway, you have, I think you have the PPT or the PDF file about this product presentation. Don't hesitate to come back to us if you have any additional question later. It's a very brief introduction about the product range for today. If you need more details about the product range, about the performance we have on one or the other product, let us know. It will be a pleasure to provide you some maybe TDS, some additional information.
Okay, thank you, Perek. Thank you for to show us this new technology, and I will wish all of you a very good day, and hope to hear from you for your next application. So thank you, Perek.